Integration tests move beyond faking dependencies to ensure that all parts of your system communicate correctly in a real-world setting. Now, unlike unit tests that use mocks to simulate a database or an API, integration tests interact with the actual AWS services. And this catches bugs that only appear when services talk to each other, like Lambda function timing out while waiting for a response from an RDS database. Now, many pipeline failures aren't caused by bad code, but by bad permissions. Integration tests are the only way to verify that your IAM roles have the correct allow statements and that your security groups are properly configured. Now, because these tests use real resources, they provide the highest level of confidence that your application is production ready. However, this comes at the cost of the time that it takes to spin up infrastructure and the small fees associated with those resources while they're active. An ephemeral environment follows a strict birth-to-death cycle that's triggered automatically by your pipeline. The pipeline uses infrastructure as code, or IAC, to provision a fresh, isolated set of resources. This ensures the test environment is an exact replica of what will eventually be deployed to production. Once the hardware is ready, the system injects seed data, which is a controlled set of database records or configuration files, so that the tests have a predictable starting point. Your test suite, which is run in code build, performs assertions against the live endpoints, checking if the data is saved correctly and the APIs return the expected results. And the most critical step is the teardown. Once the tests finish, pass or fail, the pipeline must delete every resource that it created to save money and keep the AWS account clean. Now, CloudFormation is the engine that builds and destroys these temporary environments on demand. To prevent multiple developers' builds from clashing, the pipeline generates a unique stack name for every run, like testenv-build-123, let's say. This allows dozens of integration tests to run simultaneously in the same account without any interference. Your CloudFormation template should use the output section to expose critical information, like a load balancer URL or a database endpoint. Code build can then read these outputs to know exactly where to point the test scripts. And the code build project needs permission to pass a service role to CloudFormation. This ensures that the temporary environment only has the exact permissions that it needs to function. Now, to get reliable test results, you need to ensure that your data is clean and isolated from other processes. Don't try to copy your entire production database. Instead, use a small script to insert just enough perfect data to run your test cases, even if the perfect data includes things that you know will fail. This makes your test faster and much easier to debug. If your tests use shared resources like S3 buckets, give every object a prefix built on the build ID. And this ensures that build A never accidentally reads or deletes data belonging to build B. And for resources that CloudFormation might struggle to delete, like S3 buckets with files in them, include a cleanup script in your build spec that clears the data before the stack is deleted. Now, even with automation, tearing down an environment can fail. Understanding these traps is key to a stable pipeline. CloudFormation can't delete an S3 bucket if it still contains files, so you need to programmatically empty the bucket before the delete stack command is issued. And if a resource in your template has a deletion policy retain setting, CloudFormation will leave it behind, leading to zombie resources that continue to cost you money. If a security group is still being used by an active server, it can't be deleted either. So proper use of the depends on attribute in your template ensures CloudFormation deletes things in the correct sequence. And sometimes a stack gets stuck in delete failed. When this happens, you must check the Events tab in the CloudFormation console to see which specific resource is blocking the process, and then deal with it. Now, integrating the appropriate steps into your pipeline ensures that no code reaches production without passing the gauntlet. You can handle the entire life cycle within a single code build project using the AWS CLI. The post-build phase is the perfect place to ensure that the delete stack command is called, even if the tests fail in the build phase. Now, What you need to do is place your integration tests into their own stage, after the initial build, but before the production deployment. And this acts as a final quality gate. And lastly, if the integration tests fail, then the pipeline stops immediately. And that's because the delete command is part of the teardown process. And so the